Hi guys, and welcome to today's video on parallel and perpendicular lines. It is so good to see you here, and this is part of a Methods 1 and 2 course. Yes, Methods 1 and 2. If you're out there going, hold on a moment, I'm in the UK, I'm in the USA, I'm in India, I don't know, I'm all over. I don't know what Methods 1 and 2 is. It doesn't actually matter, because this math stuff apparently is universal. So, parallel and perpendicular lines, everyone needs to know. I'm Darren, MaffsGuru. It said there in that little blue thing. If you are new, fabulous having you here. Thank you so much for stopping by. Now, if you would do me that great honour, there's a red arrow over there pointing to a doohickey in the corner that says subscribe, if you would be so kind. It's just me. I sit in a room on my own talking. I'm a little man doing a big job, and little man sounds wrong, so we'll possibly change that just a little bit. But without your support, without your subscribing, it's really weird, because otherwise I am generally talking to myself. So thank you very much. And if you can let your mates know to subscribe as well, just send a little Snapchat or a video. Come on, you won't lose that many friends. Greatly appreciated. But what is this video all about? Well, parallel and perpendicular lines, as it says. So above me, I have information that says, what are we going to do? Well, know what makes lines parallel and perpendicular. Know what it even means to be parallel and perpendicular. That was a fly. I'm trying to get out of my studio. Oh, the professionalism of these videos is just fabulous. And how to identify if equations are parallel and perpendicular, and obviously know how to use that to obviously solve equations or find. And you know, the recap's fairly small. We've been dealing with stuff on straight lines, so if you want to, there are videos previously on this series which are loading above. That's great, okay? But as this is a relatively new concept, then life is good. Now, what does parallel mean? Parallel means that they will never, ever meet, like me and most of the celebrities I would ever wish to meet. Which is weird, really, because I was trying to think recently, what celebrity would I ever want to meet if I could? And you know what? I don't know. It's weird. I don't really have fan idoldom. I don't think I've ever had a poster up of somebody I'd ever want to meet. But anyway, I mean, there was a time I would have liked to have met Steps, as in the pop group. If you don't know who Steps are, there's probably a snippet playing behind me now. Hopefully, you won't judge me too much. But the point of it is, parallel lines never meet. That was a dreadful example of parallel lines. Here we go. And how do we know if they're never going to meet? Well, math says that for lines to be parallel, they have to have the same gradient. Woo! There we go. That was a long introduction for effectively saying that parallel lines have to have the same gradient. They can have a different intercept on the y-axis. That's fine. We're not bothered about that. But if I was to look at the gradient of this, and if I was to look at the gradient of that, they would have to be identical. So in this situation, the gradient is equal to 3. Now, looking at these examples here of these lines, it's really easy in that format to look at them and go, well, because it's in gradient intercept form, the gradients are the same. They're both 3. So lo and behold, they is parallel. But what about if we have it in intercept form? Well, previous videos have stated that when we have things in intercept form, it's great, because if the x's and the y's on the left-hand side of that equal sign are the same, then the lines are in fact parallel. Now that's brilliant. So what this means here is that because we can see the left-hand side of my equal sign for both those equations is the same, they will in fact be parallel. If we want to, we could say, oh, okay, well, I've got 3x plus 2y is equal to 6. So 2y is equal to 6 minus 3x, but let's actually write it the other way as minus 3x plus 6. So y is equal to minus 3 on 2x plus 3. There we go. But what about the next equation? 3x plus 2y is equal to 8. Well, the same thing. 2y is minus 3x plus 8. So y must be equal to minus 3 on 2x plus 4. A lot of hard work, yo. Yo, what am I doing? I'm like 147 years of age and I'm going, yo. Oh, I'll be doing like this soon, but anyway, moving on. So what do we find is that, yes, in fact, those gradients there are the same, so the lines are parallel. I personally like to look at them here and go, oh yeah, that's fine. The left side of the equals are the same. What about perpendicular lines? Now, this is the one that tends to throw people quite a lot. A perpendicular line are two lines that cross but at right angles. Now, bearing in mind there are infinite numbers. Oh, look, it looks like I'm flying. There are infinite numbers of ways of these lines crossing. For it to be perpendicular, it's quite specific. And so the way we would tell that is by drawing two lines and making sure that we knew that there was a right angle there. Now, if that's the case, there is a specific rule that basically says, well, we know that for two lines that are perpendicular, if we take the gradient of the first line and multiply it by the gradient of the second line, we will always get -1. And you're going to go, ha! And I'm going to go, don't worry about it, I'll explain the theory in a moment. It's quite fascinating, really. Now, I don't really use that form of the equation. I know lots of people do. I tend to use this one here, which is the second gradient is -1 over the first gradient. Now, the reason I know this is, A, I can rearrange that first equation, but B, what that means to me is take the first gradient, and to get its perpendicular gradient, or the perpendicular gradient of a line, what you do is you flip it upside down. That's what 1 over does. When you have 1 over, it's taking the reciprocal, which just flips the fraction. And the minus sign basically says, well, if it's a minus, make it a plus, and a plus, it makes it a minus. So here's two examples quickly. Find the gradient of a line which is perpendicular to a line with gradient 2. There's lots of lines and gradients. So I know that m1 is equal to 2. So what do I want to do? I take the original number and I flip it upside down. I take that original fraction and I flip it. I reciprocate it. And you're going to go, but hold on a moment, there is no original fraction. Oh, yes, there is. Because that's actually 2 over 1. So now my gradient of my perpendicular, so my m2, is now 1 on 2. And I've got to multiply it by minus. So if it was a minus, it becomes a plus. And if it's a plus, it becomes a minus. Well, this was very definite positive. So my gradient now becomes -1/2. And a lot of people go, but why is it minus? Well, if we look at this equation here, or that equation there with a gradient of 2, well, that's a positive gradient. Positive gradient slopes up. Well, if I have a line that's coming perpendicular to it, which way must the gradient slope? It must slope down, so it must be a negative gradient, and that's why. Second example, just to drive this one home, find the gradient of a line which is perpendicular to a line with gradient -1/3. So once again, I've got m1 is equal to -1/3. So m2 becomes equal to, take the original fraction and flip it, so that becomes 3 on 1. It was a minus, make it a plus, so I'll just leave it at that. And obviously, I wouldn't leave that as 3 over 1. I would write it as 3. And there we go. Nothing more complicated than that. Now, obviously, there will be people out there going, well, all right, come on, dude, show us the theory, show us the theory. All right, let's do that. So here we go. Here's a graph, and here is a line. Now, I'm deliberately going through the origin just to make this easy for me. And let's call that O, and let's call this point here P. And so I can draw a right angle triangle, and let's call that a value of alpha. So there's P, and let's call that Q. And I'm going to have a line that's going to go through this, through the origin again, at right angles. Now, what I know is that this here is a right angle, which means if I was to choose a right angle triangle, and let's call this R, and let's call this S, then what I now know is that this angle here is also alpha, just by angles and symmetry and whatever else. They are the same. Now, assuming that this length here and this length here is exactly the same, then we're all good. How's this going to help me? Well, let's firstly look at the idea of, we know the gradient. Let's call this M1 and let's call this M2. We know that the gradient of M1 is given by rise over run. So that's going to be, we can't call that O, let's call that Q. It didn't really work. So that's going to be PQ, which is rise, divided by OQ, which is run. And I'm just going to use letters at the moment. It'll make perfect sense in just a second. Now let's look at M2. So what is my gradient? My gradient, again, is going to be rise, which in this situation is OR, divided by run, which is minus RS. Now, the reason it's minus is because we can see the graph is sloping down. Why have I done this alpha stuff? Well, let's come back to it. So we also know that the tan of alpha is equal to the opposite, which is PQ, divided by the adjacent, which is OQ. Now, that's for my first triangle here. This is for triangle number 1. If I now use trig, then I know the tan of alpha is going to be opposite divided by adjacent. And so I now know that M1 is equal to tan alpha. Yay! Let's look at the same idea here. What about alpha if I was going to use that second triangle? Well, alpha in this situation, so tan of alpha, and we can use the same alpha because it's the same one, is equal to the opposite, which is RS, divided by my adjacent, which is OR. Oh, hold on a moment. Well, we know that M2 was equal to OR over minus RS. So we would know then that 1 on M2 would be equal to RS on OR. All right, so remember, when you do 1 over something, you're just flipping it. So RS over OR. And if I take the minus sign, if I have minus 1 over M2, it gives me RS over OR. And you're going to say, well, what does that have to do with anything? Well, look what I've got here. RS over OR, which means that that's equal to minus 1 on M2. And, whoa, well, if tan alpha is equal to minus 1 over M2, and tan alpha is equal to, M1, circled the wrong thing, then I know that M1 times M2 is equal to negative 1. And I have to say, that is a funky bit of theory. Now, do you need to know that for the course? Not necessarily. Is it useful? Yes. Does it show where it came from? Yes. Is it background knowledge? Yes. Am I a good teacher? Hopefully, yes. And now let's put this into practice, because that's why you're actually here. So here we go. All of these questions are taken from the Cambridge Essentials textbook series, which is what I'm teaching from, and it is a great series of books. And thank you very much to Cambridge for allowing me to use their examples in my videos. So example number 1, find the equation of the straight line. So we're trying to find an equation of a straight line that passes through here and is parallel to this. Okay, so first things first, if it was an equation of a straight line, I'm going to use my point gradient form, because I love point gradient form. If you don't know what that is, there is a previous video that you can watch, but it's y minus y1 is mx minus x1. Now this y1, x1 business is my coordinate point. So first things first, I can put that in as y minus 2 is equal to mx minus 1, and obviously put the coordinates in the right way. But I need to find my m, my gradient. Now, the reason it's written this way is absolutely to trick people. Because so many people go, oh, it's the value in front of the x, it's got to be 2. It actually isn't. You have to rearrange this into y equals mx plus c4. So minus y is equal to minus 2x plus 4. I don't want minus y, so the best way to make that positive is to actually multiply every single term by negative 1. So y is equal to 2x minus 4. And it just so happens there that my gradient still stays as 2. That's freaky and it's a trick, but it works. So I now know that m is equal to 2. So y minus 2 is 2x minus 1. So multiply that out, gives me 2x minus 2, and add 2 to both sides, gives me that y is in fact 2x. So there we go. That is my equation that will go through that point 1, 2. Y is equal to 2x. Seemed relatively easy. Here we go to example number 2. Find the equation of the straight line which passes through, again, equation of the straight line. I'm going to go y minus y1 equals mx minus x1. Oh, now it wants perpendicular. So obviously I've got to pick up the fact that it wants it perpendicular. Well, we've got my point it passes through. So again, I can substitute that in as y minus 2 is mx minus 1. And I'm going to rearrange this equation. Now, I know that I've got the previous question to do that, but it's not going to hurt to show how to do this. So I've got 2x minus y is equal to 4. And so I know that they can rearrange to 2x minus 4. But I don't want it to be parallel to that 2. I want it to be perpendicular. So if I know that m1 is equal to 2, then my gradient is equal to flip it and change the sign. So that becomes minus a half. So substituting that in gives me y minus 2 is equal to minus a half x minus 1. I really don't like fractions, so how do I get rid of that fraction? Well, that minus a half is effectively, how do I get rid of that? Well, I'm going to double everything, right? How do we undo a half? You double, but you double absolutely everything. So I get 2y minus 4 is equal to minus x minus 1. That minus sign I'm going to multiply out, so I get 2y minus 4 is equal to minus x plus 1. Add 4 to both sides gives me 2y is minus x plus 5. And now because I want the equation of the straight line, I've got to have it y equals. So halve everything. So y is equal to minus x on 2 plus 5 on 2. Now, again, lots of people don't understand, but I can now write that as y is equal to minus 1/2 x plus 5 on 2. All right, because minus x on 2 is exactly the same as minus a half on x. And that's a huge thing that people need to get their heads around for this particular course. And finally, example number 3, before Zero, who is my puppy, drives me to distraction because he's growling all the time. at the moment is this. The coordinates of the vertices of a triangle. So you've got a triangle and it's got vertices, as in corners, are 0, -1, 2, 3, and 3, -2.5. Show that the side AB, oh, we've got a side AB, is perpendicular to the side AC. Now, you'll notice that I've actually drawn my line both that way. It doesn't really matter at this moment in time, but the idea is that for it to be perpendicular, I'm talking about gradient. This question is basically saying find the gradient of AB, find the gradient of AC, and just check that the first one is equal to the second one flipped and negated. So let's do that. How do I find the gradient? Y2, oh yeah, I know. M is equal to Y2 minus Y1 over X2 minus X1, all right? So rise over run. So I'm using A and B. So here is Y2, so 3 minus 1 divided by 2 minus 0. So let's work that out. 3 minus 1 is 4 on 2, which gives me a gradient of 2. So for my gradient of AB is 2. How am I going to work out the gradient of AC? The same way. So in this situation, M2 is equal to Y2 minus Y1 over X2 minus X1. So substituting in now, making sure that we have A and C. So it's minus 2.5 minus 1. And so 3 minus 0 goes on the bottom. And then, so what do we have? So minus 2.5 minus 1 is minus 1.5 divided by 3. Ooh, that's disgusting. So what I'm going to do is I'm going to change that to minus 3 on 2 divided by 3. And you're going to go, why on earth do I do this? Well, as a side calculation, and it's absolutely acceptable, I know that that's the same as minus 3 on 2 divided by 3. Well, keep, change, and flip. And multiplying fractions is awesome because I can cross cancel to give those as that. And minus 1 times 1 gives me minus 1 on the top and 2 on the bottom. So there we go. That is my solution. But the question is, did I prove that they were perpendicular? Well, I've got my M1 is equal to 2, and I've got my M2 as minus 1/2. Is one the reciprocal and the negative of the other one? I should cocoa. And so in my question, I would write down, hence M1 and M2 are perpendicular because, and my advice is if you're going to write it in words, write that M1 times M2 is equal to -1. And that's going to prove that you understand what's going on. Well, ladies and gentlemen, that lesson is well and truly over. Parallel and perpendicular lines. I don't know, I really rather enjoyed that, which is weird because there are so many other things in life to enjoy. Now, if you enjoyed the lesson, can you leave me a note below and a comment and say hi? Greatly appreciated. Otherwise, well, have you decided if you're going to subscribe yet? Well, there's that little clicky thing for you to subscribe if you would. Otherwise, as is normal, there is a video loading over there for you to watch as well. Seriously, if you can let your friends know to subscribe as well, I would be deeply, deeply grateful. But otherwise, MaffsGuru signing off. I'll see you next time. Bye-bye.